starting now. It's going to be called adding and subtracting polynomials. We've talked about polynomials. Have we talked about polynomials?
No.
Okay. So, does anyone know what a polynomial is? Okay. A polynomial is when your parrot didn't get any lunch, so he flew away. It's a polynomial. No, that's not what a polynomial is.
Are you recording?
Okay. Yes, I am. I can tell jokes on my recording. Okay. So a monomial, okay? A monomial is an expression that is a number, a variable, or a product of numbers and one or more variables. Each of the following is a monomial. Mono means single, okay? So it's like one term. Okay, so this is a monomial, that's 12. This is a monomial. This complicated looking thing is a monomial. And this also is a monomial. So you can go ahead. You want some time to write that down?
Yeah.
Go ahead. Take some time to write it down. Okay? At least where's that fancy computer you have to write notes on? It doesn't work anymore? Get another computer. This is Bravo got it. So, yeah, write that down. That's it. We need to write that down, right?
I would say so.
Okay?
Yeah, I would say we need to write that down.
Tell me when to go.
You don't have to write that word for word, but just know that a monomial means a term. And write a couple examples of what.
It's a term.
But you don't need all that vocabulary.
Yeah, you don't need all those words. You can abbreviate. Good. Monomial. Lunchtime minutes. I'm going to wear one of my Radical Garbage ties.
You can wear it.
No, just for funeral.
You just have to belt.
I could wear a tie with this shirt.
You sure could. If it matched.
Next week. Okay, are we done with that? Okay, I'm going to move on. You can come and revisit these notes later. Okay, next. How do you make it go? The degree of a monomial is the sum of the exponents for a non-zero constant of this sum of it, the exponents of its variables. For a non-zero constant, the degree is 0. 0 has no degree. Find the degree of each monomial. Okay, so what that means is so this one over here, okay, this has degree 0. This is called a constant term, and this has degree 0. Degree 0. It's just the power that it's raised to. What's the degree of this? What's the power over next to the x?
1.
1, right? So this is degree 1. Degree 1. And this, you have a x to the 2 and an x to the 3. So it says it's the sum of the exponents of its variables. So what is the sum of the exponents of these variables? 5. So this is 5th degree. Okay? This is 5th degree. You guys see where that comes from? What?
I also it's just the highest variable, or is that down the road?
That's the degree of a polynomial is that. Okay, so this is the degree of a particular term. So if I add up the exponents of any one term,
So you guys should write down those 3 examples that Mr. Leader has and write what the degrees are, because those will be good examples in
at
your
the
notes.
very least. I know the wording gets to be a lot. But
So you can have just degree of a monomial and then put the 3 examples.
yeah. Okay. Done? Okay, I'm going to move on to the next thing. Where's my...
Just click on this.
Click on it? No, I have to get rid of the pen. Okay. Okay, next. A polynomial. Okay, polynomial is a monomial or the sum or difference of two or more monomials. Okay, so a polynomial is lots of each one of these things are called terms. Okay, and so a polynomial, you can have a polynomial of one term, but most polynomials consist of more than one term. So this is a polynomial. Okay? And polynomials you'll learn later on, like if you take Algebra 2, which probably you will, like if you were to graph a polynomial, there are things that kind of look like this or look like this. And depending on the degree, they have different shapes if you were to graph them. Okay? And they come up a lot in real life applications of things. They really do. What? You have a real life application of a polynomial? Okay. Sure. H of t equals negative 1/2 at squared plus b sub 0t plus h0. You know what that gives you? Okay. That's a real life application. Not that you actually, I think you actually have a problem where you have to plug something into one of these. But what that is, that actually makes the shape of a parabola. And what that parabola would give you, this is time, and this is height. And that shape, that would give you the height of a ball or an object being thrown up in the air over time. Okay? But there's lots of real life applications.
So that's something we're going to learn in physics.
Yeah, it's something you would learn in physics. But also, that I think in this chapter, they actually have you plug into that polynomial and evaluate it. And that's a formula. This is the acceleration of gravity. So this is kind of tells you how much you're slowing down. This is how much speed you start with. And this is where you start from. So that's a real life example of a polynomial. Okay. Okay. So the polynomial above, you don't have to write down this whole paragraph. Okay. The polynomial above shown is in standard form. The standard form of a polynomial means that the degrees of its monomial terms decrease from left to right. The degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. The degree of 3x to the fourth plus 5x squared minus 7x plus 1 is 4. Do you guys understand why this is 4? Because this is the highest degree term. So you go by that exponent right there. That's what Miss Lindgren was referring to. Okay? So I'll have an example in a second. But the degree is based on the degree of the highest power term. Okay? So this one has an x to the fourth. So this is a polynomial of degree 4. Okay? You could write down what you want. Don't write down that whole paragraph. That's how you do that. I think I have a couple examples coming up next. I don't know where.
Concentrate on writing down the standard form of a polynomial, and then where the arrows are, I would do that as your example.
Yeah, I don't think I'm always going to have PowerPoints like this. I was just feeling ambitious.
No, I mean, it's good information.
Yeah. But that's pretty impressive. I made this PowerPoint.
It's beautiful.
Thank you.
Beautiful.
Thank you. I should have put this on my national boards.
National boards is not either.
I'm not going to pass. Do we have any seniors in?
No.
Whoa. You have to vote for prom royalty. You guys have to vote too, right?
Yeah.
Right, okay, I'm going to move on. Moving. Rolling. So, guys, this table's in your book. You don't have to copy it. You could just learn it, okay? If it has degree 1, this has degree 1 because its highest power is 1. And if it has a degree 1, it is called a linear. You might want to write these 5 things down, okay? So if it has degree 1, this is called linear, like this one. If it has degree 2, and these come up quite a bit, this is degree 2 because the highest power here is a 2. This is called a quadratic, and it's called a trinomial because it has 3 terms, okay? If you want to write this down, you can. It's a pretty
This is a
useful
great
shape.
table for you guys to write down.
Okay,
You should
I
write
didn't
this down.
make this table, I stole it.
Doesn't matter, it's still good information.
This one is called a cubic, right? It's degree 3, and it's a monomial since it only has 1 term, okay? 3 degree is called a cubic. This is called, in the book they call this 4th degree, and when you get more advanced they call it a quartic, but you don't have to worry about that, okay? So this is a 4th degree binomial because it has 2 terms. So this tells you what you call it in terms of how many terms it has, and this is what you call it based on the degree. So this is degree 0, a constant term, like this is degree 0, it's called constant, and it's a monomial. So this would be a 0 degree monomial. This is a 4th degree binomial. This is a 3rd degree monomial, and so on and so forth. We'll get some practice coming up here in a second. Okay. I'll be done in about an hour. No, about 15 minutes. Then you have some time. We're good? No. Done, Megan? Good. How was your spring break? Good. Did you do anything safe?
Went to Vail.
Vail.
Yeah.
Was there snow?
Kind of.
Did you go ski?
Yeah.
Hey, okay. I went to that. Hey, uh-oh. Oh! Go back. Oh! Go back. Oh. Stop that. It's malfunctioning. Okay. Okay, we're going to move on.
Now we move on. Okay.
Now can I move on?
Yes.
Max? Alright, go. Right here. I can't see my job. Okay, here we go. Write each polynomial in standard form, then name each polynomial based on its degree and the number of its terms. Okay, so who can tell me what this is called? It's not a monomial because it's got 2 terms, so it's called a binomial. And what degree is it?
1.
Right, it's a 1st degree. So this is called a first degree monomial.
I thought you said it was a bi.
Yes.
Oh, sorry, that's wrong. You're right. Binomial. I didn't write that very well. But, hey, that's what you do if you're cheap when you take someone out to lunch. You binomial. Oh.
Binomial.
Okay. Okay. Next one. Okay, so this one's a little bit trickier. Do you guys know what I could do? So this one's pretty tricky because you have 2 things that are the same. Altogether, how many, this is called combining like terms. We haven't done this yet, have we? Put all the terms together that are the same. How many x to the 4th powers do I have? 3 and 5. So altogether, how many x to the 4th powers do I have? 8. So I'm going to write this as, and I'm going to arrange it from the highest power. So this is 8x to the 4th. What's the next higher power after x to the 4th?
2x to the second.
to plus 2x to the second minus 4.
It's clear we get that.
So that's, first you have to combine your like terms. And like terms are terms that have exactly the same x's in them. So an x to the fourth and x to the fourth are called like terms. Okay? So I have 8x to the fourth is all together. And this thing in front is called the coefficient. In front of the thing in front of the x to the fourth, that's called the coefficient. I thought we haven't talked about that? No. So who can name this for me? What degree is it?
It's
It's a fourth degree what?
trinomial.
Very good. Fourth degree. Tom said it's a fourth degree, and Freddie said trinomial. Okay? That's what you do if you don't want to get food poisoning. You trinomials. Fourth degree trinomial. My jokes are getting old. Okay, should we move on?
Let's see, is it a big function?
Move it on. Move it, roll it. Keep them dogging. You try. Who wants to get this one right? So what you're supposed to do, arrange this from highest degree to smallest degree and then name it. I'll give you a valuable participation point. Tell me the answer to that one. Okay? You try. Look at this. Isn't this an amazing PowerPoint that I made? This one great. I deserve a pat on the back. Okay. Well, thanks, I got that one. Clayton's got it. First, rewrite it for me.
Y3.
So, yep.
3y.
Not plain old y3. It's going to be negative y3. Okay? Negative y3. What, Clayton? Not minus 3y. Plus 3y. Minus 4. And what's that called? What? It's a trinomial. What degree trinomial is it? Third degree, or what's the other name for it? Cubic. Good. Okay. So we would call that a cubic trinomial. Okay. Trinomial. We got to give CM a point. Okay. Do I have another? Very good. All right. Next. I'm moving on. Okay. So now we have adding polynomials, which can get, this can get a little bit confusing, but it's really not bad. So the things that, so there is one method that you can do it, adding vertically, okay? So like I said before, these things are called like terms. So you can combine like terms. So the 4x squareds and the 2x squareds could go together. The 6x and the minus 9x can go together. And the constant terms can go together, okay? So you line them up. The x squareds with the x squareds, the x's with the x's, and then you just add straight down, and that's what you get, okay? Any questions about how you do that? Can you do that? I'll let you write that down. That's a good example. Okay. Yes, yes. You have to make sure that these things are the same degree term, right? Or the same, that they're like terms. So all the x squareds go together. All the x's will deal with one where they don't all match up. Yeah. Okay? Okay? Are we good with that?
Add these two colors.
2 colors. Yeah, look at that. I even made different colors. I stole this from somewhere.
Of course.
It's always good to steal.
I think opposite of that.
Okay. So let's see what's next on my powerful PowerPoint. This is called the horizontal method. Okay?
Wait, can you go back for a second?
Can I go back for a second? Sorry.
I think vertical one's better.
Yeah, I like the vertical method better than the horizontal method. But you can't, just so you know, you can't do the horizontal method. Wow. That's a lot of things. Got it all. Okay, moving on. So you can also add horizontally. So what they did here is they took this is the same problem, isn't it? Is this the same problem?
No,
They
it's
just,
different,
yeah, it is. So they just took the x squared terms and they moved them together and then put parentheses. And then they took the x terms and they put them together and did parentheses. And then they took the constant term and they end up with the same answer. So that's called the horizontal method, which I think is kind of a little more confusing. But if you're doing it fast, you know, like this is how I do it because I can kind of do it fast in my head. But you guys probably, for now, you want to use vertical method.
But
Right?
if you have to stack them.
Your turn. Look at this. Look at this. I should have done this in my time. Look at this. Okay, here we go. Your turn. Who's going to tell me the answer? Go ahead. Someone raise their hand in a couple minutes and tell me the answer. Besides Fred.
Darn it.
I'm going to give Fred a point already for participating so much. Okay. Emma has it. Let Tom go.
20m squared plus 9.
20m squared plus 9. Is that what you got? Yeah. Okay. So, did anyone not get 20m squared plus 9? So this one's pretty easy one to do. So we combine the like terms, right? And so we have 12m squared and 8m squared, which makes 20, or you could make them line up, right? 12m squared plus 4 over 8m squared plus 5, and then you just add together. So you get 20m squared plus 9. Or you could have done the horizontal method either way. All right, almost done. Almost done. Did we do your turn? Ooh, this one looks more harder. Who wants to try this one? More harder. Yeah. Haven't you ever taken any classes from Dr. Curley? Because it's more better. He's fun. He's probably he was like 80 about 6 years ago. Yeah, okay, go ahead, Clayton.
11p cubed.
11p cubed, yep,
17p squared.
plus 17p squared, yep,
And then 13p.
plus 13p. Does everyone see what Clayton did? Okay, he combined his cubed terms, right? There's your cubic terms. There's his squared x terms. And there's his, those are called linear terms, okay? And very good. Clayton got that one. Okay. Next one. Okay, and then we have subtracting polynomials. We're almost at the end. Have no fear. Okay? So if you have subtracting polynomials, you line up the like terms. So notice in this one, okay? Notice in this one that this is kind of what Ms. Lindgren is talking about as well, okay? Is that, see how here I have an x term, and here I don't have any plain old x terms. Here I have an 11 term. So what you do is you want to write this one as 2x squared plus 5x squared minus 3x minus this one, but I line up my x cubes, and I line up my 8x squared, and then there's nothing to go with the 3x, right? And then the 11 goes over here all by itself, because you can't subtract the 3x and the 11. And then it's minus the whole thing. So you put this whole thing in parentheses, and then you distribute the negative sign through. So this becomes negative x cubed. A negative times a negative makes a positive. A negative, there's 0 here, so you don't have to do anything here. A negative times 11 makes 11. And then you just add. Okay, so 2x cubed plus negative x cubed makes 1x cubed. There's a 1 in front of here, but they don't show it, right? There's a 1, but it's understood. 5 and 8 makes 13, minus 3 and 0 makes minus 3, and that makes minus 11. Okay? So I think I have some you try ones in a minute. Let's see what's next.
Darn it.
So here's, you can do it with the horizontal method as well. And so here we have 2x cubed, and they just distribute through the negative sign. So this becomes negative x cubed, that becomes negative negative, which makes positive, and that becomes negative 11. And then what I usually do to indicate like terms, like I'll put 3 lines under the x cubed terms, right? And then I'll combine them. So 2x cubed minus x cubed makes 1x cubed. And then 5x squared plus 8x squared makes 13x squared. And minus 3x plus nothing just makes minus 3x minus 11. Okay? So I think I have a couple of you tries, and then we're about done. Okay? Then we are done. So here we go. Let's see. You try. Who thinks they can tell me the answer to this problem? Someone other than Clayton, Freddie, Tom. 2 more problems, then we'll be done. Look at Tony, you look so smart with those glasses on. You look very erudite. You don't know that word?
How do you spell it?
E-R-U-D-I-T. Erudite? You never heard that word? You guys have never seen that word? Let's look it up. I like words.
I've seen it. I just.
Where's my dictionary? We could Google it. But I think it means smart. That's what it means. Look at Elena's glasses. Those are pretty suave. Are those new glasses? Let me see. Oh, you look very astute and erudite. Very nice. All right. Okay, who thinks they got the answer? Who thinks they got the answer? Come on, you kids. You can do it. I'll give you 10 seconds. 15 seconds. Who's got the right answer? Look, I even have a stopwatch. Emma, are you going to answer this one? Come on. Just combine the like terms. It's easy. Brittany. Alec. Maximilian. Go ahead.
10z cubed.
No.
That was fast.
Michael Minicello.
Is it negative 8b cubed?
Yep. Negative 8b cubed.
And then plus, minus,
Minus.
13.
No. Oh, no. No, it's plus. You were right.
Oh, yeah.
Plus
13b cubed.
b squared.
B squared, that's nothing, sorry.
Right? And
Minus 4b.
minus 4b. Yep. That's what it is. Okay? So, look. This is what I'll give you a point. So, what I would do, this one you just leave alone, right? Then this one becomes minus, distribute through the negative sign. So it's minus 9b cubed plus, because it's minus a minus, so plus 7b squared. And minus a plus makes minus 3b. And then you just look at each term individually, right? So I have 1b cubed minus 9 makes minus 8. Then I have 6b squared plus 7 makes 13b squared. And then I have minus b minus 3b, which makes minus 4b. Okay? So Michael got that one. And the last one, and then I think we're done. Good? Last one. We did that one already. You try. Easy. Not much harder. Who's got it? Go, go, go. You can do it. You gotta do it, do it, do it by the book. The yellow tape. Never mind. Just memories from my childhood. Old TV commercials. My question? I did. Claudia, are you going to answer this one? It's muy fácil. Did I say that right?
Yeah.
Not really. Take Manny. Tim Tebow's not even going to play quarterback. He's going to play running back.
That's better.
And he's getting married to Taylor Swift. Okay, Elise, fire away.
See if they go complete.
I got negative 2x squared plus 4x minus 7.
You got it right. Negative 2x squared
So this
plus 4x minus 7. She got it exactly right. Very nice. Okay? So, so you can line them up and do it that way if it helps you. Or you can just, like I do them in my head, I go, what's 4 minus 6? That makes minus 2. 5 minus 1x makes 4x. And 1 minus 8 makes negative 7. And then we're done.
Well, don't you have to make all those negatives, so it would be 4 minus negative 6?
No, because it's 4 minus positive 6, right? Okay? And it's 5 minus positive 1. And 1 minus positive. Okay, so I think we're about done. Let's see, look at this. I even have your homework up there. I should always do it like this. Makes my life easier, doesn't it?
Do both.
Do both. Sure. Okay, so your homework is page 459, 1 through 52. Every